Hello, I'm Jeff Mucklin, and this is Science at Home, which is brought to you by the Nurture Nature Center. There are few natural phenomena more beautiful, more mysterious than aurora. More commonly known as the Northern Lights, they are rarely seen outside of the polar regions. Occasionally, though, they are visible closer to the equator. This is exactly what happened in the early morning hours of May 11th, 2024. The word aurora refers to these lights more generally, but they do occur over the north and south poles of the Earth. The northern lights are called the aurora borealis, and the southern lights are called the aurora australis. They typically occur near the Arctic and the Antarctic Circle, and they typically form an oval or a ring shape. So they're not usually seen directly over the North and South Pole, although they do sometimes appear there, and they are very rarely seen anywhere near the tropics. They come in many colors, including blue and violet, green, orange, and red. They are a complex result of interactions between the Earth's atmosphere, its magnetic field, and the sun. The sun is constantly blowing off material into space. We call this the solar wind. And I'm not talking about light, but actual matter in the form of mostly hydrogen atoms that have been stripped of their electrons. When any kind of atom loses its electrons, we call it a plasma. Plasma is a state of matter like a liquid, solid, or gas, and it's most like a gas. But one of the key differences is that plasma is actually a very good conductor of electricity, and it responds to magnetic forces, unlike gases. Here I have a plasma ball novelty light, and if I place my hand on it, you'll see that the electrical charge in the plasma is attracted to my hand, for example. The sun's plasma is blowing out in every direction, and the individual particles that make up the plasma are moving at about 1 million miles per hour, which is about 600 times slower than light, but it's still pretty fast. The Earth is about 91 million miles away from the sun, so it takes these particles, even at that speed, a few hours to days to reach us. These particles carry a lot of energy, though, when they arrive at the Earth. They are moving fast enough that they would actually represent a harmful form of radiation, not too different from alpha or beta radiation. And if we were exposed to it on the surface of the Earth, life would actually not be possible. But we are protected from this lethal onslaught by a literal force field. To see this force field in action, simply grab a compass. The needle of a compass is sensitive to magnetic fields. If I hold this magnet near the compass, you can see I can make the needle move wherever I want. Well, the Earth itself generates a magnetic field. It has a large magnetic field all around it, and we call this the magnetosphere, and it deflects the plasma wind of the sun away from the Earth because plasma is sensitive to magnetic forces. But not all of the plasma is deflected. Some of the plasma isn't pushed away. Some of it is actually pulled in along the magnetic field, but only near the magnetic north and south pole. Luckily for life on Earth, the amount of solar wind that pierces the magnetosphere is small, but that little bit of solar wind packs a serious punch. As these particles come closer and closer to the Earth, they are more and more likely to encounter an atom of gas in our atmosphere. These atoms absorb a lot of energy from these collisions, and when atoms absorb energy, they emit light. Actually, every element produces a different color of light when it absorbs energy in this way. And if we hold something called a diffraction grating up to our eyes or up to a camera, we can see this spectrum of light. You can see that little rainbow right here. Now, our atmosphere is made of a mixture of mostly nitrogen and oxygen, which is going to have a unique spectrum. And I have over here actually a device that can pass enough electricity through various gases to cause them to produce light. It ionizes the gases, turns them into a plasma, and they produce light. This is the light that is given off when neon and argon gas turn into a plasma and emit energy in this form. And if I hold my diffraction grating up to it, you can see a band of colors right over here, and that is the unique spectrum of this mix of neon and argon gas. Each of these tubes has a different gas or mix of gases in it. The pressure of the gas in these tubes is very low. It's very similar to the air pressure very high up in the upper atmosphere. We can produce the exact same kind of light that is produced by the aurora if we pass enough energy through these gases to get them to ionize. This is the color produced by oxygen gas. If we look at this light through a prism, we can split it into its individual colors. This is the color produced by nitrogen gas. Through the prism, we can see it is composed of a little bit of red and a lot of blues and violet. And here we see a mix of these gases. Now watch what happens when I put a very strong magnet near the tube. When I first saw this, I practically jumped out of my skin. You can clearly see the magnetic lines of force that are mostly pushing the plasma out away from the magnet, but actually pulling it in near the north and south pole of the magnet, producing little arches that are essentially mini auroras. So why were the northern lights visible this far south recently? The sun's production of the solar wind actually fluctuates. Sometimes the solar wind is so weak that there are no aurora anywhere, sometimes for months at a time. At other times, the solar wind is strong enough to see the aurora in the normal places, and sometimes the solar wind is a little stronger than usual, so the aurora becomes visible, a little further south than usual, maybe along the US-Canada border, for example. Very rarely, when the sun is extremely active, the aurora might be visible this far south. Now, the sun has an 11-year cycle of activity called the solar cycle, and right now it is in the middle of a peak in activity. Large solar flares have been happening for months, and this is going to continue into 2025. And on the 10th of May, I heard that the largest solar flare in 20 years had just occurred. But this one was big enough and it was pointed right at the Earth. But I went out to this field that I'm standing in right now, a darker spot of the field back there in that dark void back there. Around 2 o'clock in the morning, this incredible dome of light stretched across the entire northern horizon. It had patches of pinkish purple to the west and east that faded to green directly north. The patches of color would kind of slowly morph, and for a brief period it was actually pulsing rapidly, which was something I didn't even know was possible. It was simply stunning, and it was one of the most beautiful things I have ever seen. As beautiful as they are, aurora are a warning sign that the sun is able to affect the Earth in some surprising ways. In 1859, for example, a massive solar flare called the Carrington event occurred. And it caused aurora that were even brighter and seen even further south than what happened recently. Now, if a solar flare of that magnitude were to hit the Earth today, it would be a major catastrophe. If grid operators didn't see it coming, it would likely induce currents powerful enough to destroy most of the transformers on Earth, like the ones at this electrical substation here behind me. There's a period of hours or days between when we see a solar flare on the sun and when the plasma reaches the Earth. So we could probably disconnect this kind of equipment from the grid and likely save it from dangerous power surges. Scientists are constantly observing the sun and producing forecasts that grid operators, internet providers, and satellite operators all use to keep our modern technology working. These models are very good at predicting how much impact a solar storm will have on our planet, but we don't know why it's an 11-year cycle or why some cycles have a stronger peak than others. Now, if you want to see the northern lights, I wish you the best of luck. I can give you some pointers. They're too dim to see when the sun is up, so you're going to have to wait till nighttime. And you're going to need clear weather. Other than that, your odds are better if you can spend some time very far north, like in Alaska or Canada. If you follow the news, you should hear about large solar storms and solar flares. But this website that we're going to share right here is a great place to check the aurora forecast. And if you go to a dark enough spot and the conditions are just right, you just might see something incredible. Thank you for watching, and I'll see you next time.